All right, so everybody, find the volume of the solid by rotating the region about the bound curves. Okay, typical, sketch the solid, the typical disc, and the washer. So guys, first of all, it's about the y-axis, x equals 0, y equals 4. And it's going to be about the y, so I'll put my arrow here right away. It's about the y. I would graph x equals 0 first, and y equals 4. Guys, there's your two horizontals. Everybody, if you don't recognize this curve, this is x equals 1/2 y squared. Guys, it's a parabola rotated on side. Open it up. So everybody, I don't have to graph the whole thing. You guys agree there's a curve down here? But I don't have to graph it all. Everybody, I know this intercept. I want to be crystal clear. Do I care about the x value here? I don't. Guys, I don't care about this x point because I know this y line is at 4. If I'm revolving about the y, my cross section is going to be right here. Guys, that's going to revolve this way. Everybody with me? So everybody, I think that area is dy thick. So everybody, this is C to D, AY, DY. And everybody, if you revolve this about this, it's going to be a circle, right? When you cut it, it's a circle. All right, let's fill in our x, y values. It's going to be 0 to 4, right? You're going to sum up all these circles from 0 to 4. That's how you pick these. And I'm going to write all the extra steps today. Guys, it's a circle. Can't integrate r with respect to y. So everybody, I look on my board, and I look here, and this length, this radius, is x long. So this is actually, I'm going to put the pi out front like we always do. It's x squared dy. But everybody, I can't integrate x with respect to the partial dy. What do I know? Oh, well, I know 2x equals y squared. So what's x equal? X equals 1/2 y squared, everybody. There's your x. Oh, so let's get rid of that here. And I'm going to make the view a little bit smaller. And this is where we screw up. This is where we screw up. This is where we screw up. Guys, it's not 1/2 for a coefficient. Half times a half. It's a fourth. And everybody, at this point now, I'm going to write what we have to integrate. I'm going to change colors to green. Because now we have what we want. It's going to be 1/4 pi on the outside as a constant. Half squared. Pi's here. Y squared squared. Ignore that mark. That was an extra mark. It's y to the, I think it's y to the 4th dy. Everyone, it can't get, from 0 to 4, it can't get any easier than this. Because this is a super simple integration. All right. So everybody, I'm going to slide over. Can everybody picture the solid? Here's our, look, there's the curve from the book, right? There's mine. And guys, there is the sketch of the solid, right? Revolving about the y. There is the disc or the solid circle of dy thickness. We just got to finish the integral. So it's, we'll do that in green. So it's 1/4 pi, print y to the 5th over 5 from 0 to 4. So guys, it's 1/4 pi, 4 to the 5th over 5 minus 0 to the 5th over 5. Again, it's 0, but I want you to make that consideration. Everybody, AP people, listen carefully. You really want to know that 4 to the 4th is 256. I see 4 to the 5th and 1/4. It's 4 to the 4th. So 256 over 5 pi, right?
I'm so glad I
And there's our answer, okay? And everybody, I can't stress enough, if I make this a little smaller so it all fits on the page for the YouTubers out in the world. Everybody, is it always dy? Right now, is it always going to be dy if you're going about the y-axis? Yeah. Or if you're going around another axis. Guys, vertical axes are going to be dy. Horizontal axes that you revolve around will be dx. But guys, that's not the rule for always. That is not the rule for always. We have to be able to picture what we are summing up. Guys, we are summing up all the circles from C to D vertically. That's why it's dy. That sets the thickness. Number 6 in Stewart 5.2.